Hey guys, welcome to another video. In this video, we are going to solve this question by following the properties of determinant that we have discussed in the earlier video, okay? Therefore, while I want to modify this determinant to take some form that we have explained in earlier videos, like the column having the identical rows, identical columns, or having zeros, as well as I want to perform row operations or column operations and look for the determinant by following these rules, okay? So my first thing is I want to take some scalars out, so that I want to follow this rule number 1, okay? So to do that, it seems wise to do the column operations, okay? Therefore, I want to do column operations by following the rule number 3, but in the column form. Here it is row form, but I want to do column form, okay? So I have column 1, column 2, and column 3, okay? I want to operate this column 1 by subtracting this column 1 from column 2, okay? And I want to modify this by subtracting this column 2 from column 3, and I want to modify column 3 by subtracting column 3 from column 1, okay? So if you observe very carefully, here what I have done is I have multiplied this column 2 by scalar of -1 and added to the column 1, which means I am exactly doing this but to the column. So our determinant value will not change. So while performing this kind of operations, you neither have to worry about the value of determinant because it will remain same, right? So by doing this, we will get p squared minus q squared, right? And here we have r common, so take r as common and do q minus p minus q, okay? And column 2 also will get q squared minus r squared, and here we have p as common, so take p as common, and what's left r minus q, and here q minus r is left, right? And here column 3 minus column 1, so we'll get r squared minus p squared. Here you see q is common and we have p minus r, and here r minus p, okay? So if you observe very carefully, these are the differences of the square, okay? Therefore I can express this p squared minus q squared as p plus q, p minus q, right? Similarly q plus r, q minus r. Similarly r plus p, r minus of p, okay? So what I want to do is I want to take this q minus p as a scalar. You can take p minus q also, but I want to do this, okay? You can try this. I want to take q minus p as scalar, which means I have to modify this and this one, right here. So if I take negative out and do q minus p, okay, then it will be same as p minus q when we distribute this negative back, okay? So here also we can do negative q minus p like that, okay? As well as I want to take r minus q as the scalar, so I have to modify this and do r minus q, and here also negative r minus q like that, okay? And here I want to take r minus p as a scalar. I have to modify this and take r negative r minus p, and here it will remain as it is, okay? By doing this, we can take this q minus p as common from this first column, column 1, column 2, and column 3, okay? So by taking this, we will get q minus p, okay? And from here we want to take r minus q as common, and from here we want to take r minus p as common, okay? So I have just followed this rule number 1, okay? So by doing this, negative p plus q, right? And here r, and here is -1 because we took this, right, q minus p, so we will get -1 here. And we have r minus q, so negative will be here, so we will get negative q plus r, and here we are taking r minus q, so we will get p, and here we'll get -1. Okay, and here we took r minus p as common, so we are left with r plus p, and here we are left with minus of q, and here we are left with 1, right? Because r minus p is here. So this one I took it from column 1, this one from column 2, and this one from column 3. So exactly this one I followed the rule number 1. Okay. Now if you observe very carefully, I can further do some operations to simplify this. Okay. So what I want to do is I want to operate this column 1 by adding this column 1 with column 3. So if I do that, what I will get is I will get r plus p minus of p minus of q, right? So p will get cancelled, so r minus q. Okay, so if I add, we will get r minus q here also, and here -1 plus 1 which is 0, right? So I will end up with the value r minus q and 0, so that we can take this r minus q further as a scalar. Okay, as well as I want to perform operations for column 2 by adding column 2 with column 3. Okay, so when I do that, what I will get is I will get p minus q from the first, and then the second one is p minus q, and this one -1 plus 1 is 0, so that I can take p minus q as common. Okay, by doing this operation, what I will get now, I will get r minus q, and here also r minus q, and -1 plus 1 is 0, right? And here I will get p minus q, and here p minus q, and here -1 plus 1 is 0, right? And I will keep r plus p, -q and r, because we didn't apply any operations here. Okay, times the scalar. Now q minus p, r minus q, r minus p. Okay, now if you observe very carefully, we have r minus q from the first column and p minus q from the second column, but we have here q minus p, right? So that we can modify this to negative of p minus q here, like that, right? So here we can take this as common term from column 2. So at last what we will get is we will get r minus q will get squared, right? So we will get again r minus q times r minus q, because we are taking one more time, so it will get squared. So we will get r minus q the whole square, right? Negative p minus q times here p minus q by taking this, right? So we will get r minus p as it is, right? So that here we can modify this to negative p minus q squared, right? So by doing this, we'll get r minus p, like that. So by doing this, our determinant will get modified to 1 1 0, right? So 1 1 0, r plus p, negative q and 1, right? Now if you observe very carefully, finally we have reduced to the determinant, the predetermined value. Okay, and if you observe very carefully, we have that this c1, c2 and c3, c1 and c2 are identical. If you observe carefully here, this c1 and c2 are identical, and these are the scalar. Okay, therefore this whole determinant, this value will be simply 0, because we have learned that the determinant of the matrix with identical column or rows is 0, and these are the scalar. Therefore our determinant is finally 0. Okay, so we will say like the determinant is simply r minus q the whole square minus of p minus q the whole square times r minus p times This one is 0, so it is exactly 0. Okay, therefore what we have done is that we did the modification according to the rules, and we took out a scalar as said from this rule number 1, and then we have modified this determinant which has some form which is identical columns to deduce that this determinant is simply 0. Therefore, the determinant value for this is exactly 0. So this is how we have to do, and you have to be very careful while doing the operations, because you have to do in such a way that when you do, it should make sense and it should follow these rules. Okay, I hope you have understood this video and enjoyed this video, and I will upload more on this to make sure that you understand more, and this is very fun actually. So I'll see you next video. Thanks for watching. Bye.